how to do the insertion sort is the next thing we're going to do. I've given you a video of me doing the insertion sort but missing out a load of steps. That was the first video I gave you. Then the second video by hand, I included the steps that I missed out, and it is quite complicated to follow along. And now I'm going to write the program that goes with it. Now on the first version that I gave you, there's insufficient information in the algorithm to actually write the program. However, on the second video, where I take each and every single step, then there is sufficient information to actually write the program, and that's the one that I'm going to use to write this one now. So I'm going to start a new file, and it'd be better if I was in idle. And I'm going to save that on my desktop as insertion sort. Now this isn't easy by any means. I don't expect you to be able to write this code or remember this code. The algorithm I would, and we'll deal with algorithms a little later in pseudocode. So we'll see those as part of our revision for all of this. But there is no way I want you to be able to write or remember this code. What I do want you to do is be able to download the code and to use it so that you can check your handwritten methods. So that will be quite important. So we're going to start as we did with all the rest of our program so far by having the main part of the program. So if I have the main part of the program here and have the call and set up my array. So here's my array 4132. We'll use it as we did in the example, the same data. And then I will have a call to my insertion sort and pass it the argument of data. So I'm kind of building my program in a decomposed fashion. So I'm breaking it down. And actually what I really want to do is when I return the value, I want to print it out to the screen. So I've got a function that I need called insertion sort, and it needs an argument to hold data. So I'm going to do that at the top. Define the function insertion sort and give it the parameter d. And at the moment I'm just going to write pass so that if I save and run the program there's going to be no mistakes, so it's not going to crash. But I'm not going to keep running the program as I go through it. I'll probably just run it at the end. Now what's going to happen is that I'm really going to decompose this because the insertion sort actually has several parts to it. So if I put at the top my array, now this isn't part of the program, this is just demonstration 4132. What's really happening is that we're splitting this into kind of two lists. So let's put some space between them, or two arrays. So I've got one on the left, which is sorted. And if I've only got one item in my array or list, then it's definitely sorted. And then an unsorted section at the end. Now the insertion sort is going to treat each and every one of these items in the right hand side. So we're going to go through it. So we're going to start off with 1, then 3, then 2. So we're going to loop through this list. So we need a loop to do that. And when we run out of elements, then we're going to stop and the list should be sorted. But what will happen, and what the manual method on paper did, is it took the item. So let's take the item from the right-hand list, from the unsorted list. It took it out. And if I just put that to one side, so I'm dealing with 1 here. And when it did that, what it did is amended the left-hand list. So it actually put that blank, the underline, on that side and shortened the list on that side. So it took the first element from the unsorted list and kind of expanded the sorted list on the left-hand side. Now, what we really need to do And here's the first part, is find where that 1 goes. So we need to do a search. We need to look on every element in the left-hand side and see where it goes. Now, if it's more than 4, if it's bigger than 4, it's going to go to the right. So if I was dealing with 5, it would end up being there. But as I'm dealing with 1, it needs to go where the 4 is. So there's my search. So there's the second algorithm that I need as part of my insertion sort. And we'll deal with that shortly. The next algorithm is, well, if I need to place it before the 4, what I need to do is get rid of the 4 from this position, because that's where my 1 goes. And I can't just write my 1 there. If I did that, I would lose the 4. I actually have to move, the 4 one place to the right, or shift everything to the right, one place to the right. So I'm going to move that 4 and put it where the blank is. Do it again. And then put my underline there, because I found the position where the 1 goes, and then place the 1 in the list at that point. And once I've done that, this side is sorted, this side remains unsorted, and then I can move on to my next element. So I look in my unsorted list, the next element I've got is 3, so I'm going to put the blank there and take the 3 out, and then I'm going to join these two lists kind of together with a blank there and reduce the size of that list and perform the same actions again. Find out where the 3 goes. So I've got a search looking for where the 3 goes. It goes where the 4 is. So I need to shift the 4 one place to the right, have the underscore there, and then insert the 3 at that position. And that is the purpose of the insertion sort. So I've got 3 algorithms that I need to go with. So having said that, which is probably very confusing, but go through it slowly, it's exactly the same way that I did it by hand. So I'm now going to write that as code. So I'm going to use longer terms, variables, to mean something. So actually, let me just put that back at the top. It won't run the program, but it might give you some idea of what's going on. 1, 3, 2. There we go. So the first thing I need to do is do my loop over all of these elements in my array. So I'm going to say for the current element. Now the current element is the first item in the second part of my list, in the unsorted part. So it's actually position 1 as an index in my original array. And if that is, well, let's just do it in the range of the length of the array minus 1. So the reason why I've done that again is current element is going to start off at 0. And it's going to run for the range of the length, which is 4. So it's 4 elements minus 1. So the indexes are going to go from 0, 1, 2, 3. So I'm going to run across all of those elements in the array. Now I'm going to sort of split the array up now, and I'm going to say that the end of the sorted part, and this is going to change as I go along, the end of the sorted part is equal to, well, if the current element is 0, the end of the sorted part is here, 1. So it's 1 on from the current element. So that is the current element plus 1. So that's where the end of the sorted list is. And that item is the item that I want to pull out and make a blank. So I'm going to say that the item to insert is equal to whatever is in the array at the position current element going mad is the end of the sorted part. So if the end of the sorted part is the current element, which is 0 plus 1, that one there, then the item to insert is now going to be that 1. So I'm pulling that out of the array. The next thing I need to do is find the position of where I want to insert it. So I've got another little function, so I'm decomposing it. I'm going to say find the insert position, and I'm going to pass in some parameters shortly. So what's going to happen now is that it's going to look along here to find out where I need to insert it. It's going to return the value position. Okay, so once this has done its job, I will have found the position in my list. So I need to call that array. I'm just going to copy this and paste it in there. So it's going to call that array, but now I've got to figure out what I'm going to send it. Well, it needs to know what the data is. So I need to send it the list or the array. And then I need to say, well, we need to start at this is just the search routine that we did earlier. So I need to start at the beginning and keep looking at each element in turn to see if I've found the position. So I need to give it the starting value, and the starting value is always going to be 0, because whatever value I have might be the very first item in the list. And I need to run along just this sorted part. I don't need to even worry about these bits here. So what I need to send in is the end of the sorted part. So it's only going to do the smaller part of the array. It's just going to look inside here where it needs to insert itself. And also I need to send in the actual item that I need to insert. So copy that and paste that in. So I've got 4 arguments to send in: the array, the start position of the sorted part, the end of the sorted part, and what I want to insert into it. So I'm going to put the arguments in here. So D I'm going to keep as my data. I could change that. In fact, I'm going to change the next one because it's going to run along the list. So instead of being 0 static, it's going to change. It's going to start off at 0, and then it's going to look at the next element, and it's going to look at the next element. So I'm going to call this one the current position. And the current position is going to start off at 0. And then I've got my end of sorted part. So I'm going to call that end of sorted. Instead of part, I'm going to call it array, just so that you can see that we can have different names for the same item. So here's the argument, here's the parameter, and we'll discuss a lot more about that when we come to use something called scope a little later on. And finally, the item that I intend to look for. So that's all the variables I need at the moment. I might need more. We'll figure that out later, but I think I've got them all. And what I'm going to do is, once I've found the position where it needs to be inserted, I'm going to return that back to the main program. So I'm going to return the position. In fact, I'm going to return the current position. Because current position is going to be where I am currently at. And once I found it, if it's there, that's the value I'm going to return. So if it doesn't find anything, I send in 0 and it doesn't find anything, it's going to return 0. So let's see how we're going to use this to search for the position. The first thing I need to do is say whether I found it. What I'm going to do now actually is I'm going to change this back to the array that had blanks, because really this is the situation that I've sent in. So my list is going to contain at the moment, for the first one, 2 elements. So I'm going to set found equal to false to say that I haven't found it yet, which is quite obvious. And then I'm going to loop through all the items in my sorted list to see where it is. So while, and I'm using a while loop because I don't know how many items will be in this list. It's going to change. If it was, if I knew how many items, I would use a for loop. So I'm going to use the while loop, and I'm going to say while the current position is less than or equal to the end of the sorted array. Now that kind of makes sense, because if the end of the sorted array is here, I'm just going to loop while my number is less than here. So if it starts, if the current position becomes here, it's gone beyond the end of the sorted array, and that breaks the loop. And what I will know at that point is that I need to insert there. And I've not found it. So it's going to loop while it's not found. Now, if I find where I need to insert the position, I don't want to keep looping over everything else. I need to say, hey, stop, I need to insert there. So that's what the found variable is doing. Now I've got to check the item, which at the moment would be 1, with the value that's in the current position. So if the item is less than or equal to, because it could be 4, and if it's 4, I need to insert it right here and move the 4 across, so I've got 2 4s. If the item is less than or equal to whatever is in my array, now remember that the array that I'm sending in is only this big. It's not the whole array this time, even though I've used the same variable. At the current position, now current position is 0, so we're checking to see if item, which is 1 when I first go through it, is less than what's at the current position. Well, this one is. And so I have found where I need to insert it. If it isn't, if I haven't found the location, I need an else part. And all I need to do is increase my current position. In other words, look at the next item. So on this one, I'm going to, well, let's just copy and paste it. That'll save me a little bit of time. I'm going to make the current position whatever it was plus 1. So when it was 0, it's now going to be 1. And then I'm going to keep looping through the array. Now, if it gets to the end of this array and it hasn't found anything, then we know we need to insert it at the end. So that's my position. So in my main part of my program, position is going to come back where I need to insert my item in the array. So I need to check that. So I need to check that if the position is equal to the end of the sorted part, if it's this item here, so let me just take that, copy that. If it's the end of the sorted part, then all I need to do is insert it at that position. So I can now say that the array at position equals the item to insert. So let's copy and paste that. So that dealt with it if we'd got the position at the end. However, if we are where the 4 is, what we need to do now is move the 4 right and insert where the 4 was. Now that's a little bit of a problem because I now need yet another function, another algorithm to move everything right. So let me just do my else part, and I'm going to call my function move elements right. So I'm going to set that D equals, because it's going to return an array, so it's going to start off with the 4 and the blank, but when it's moved everything right, it's going to return a blank and a 4. So this part of the array is going to change. So in other words, I'm just going to put a blank where the position to insert is. So D equals, let's say, move elements right. So I've got a function to move all the elements right. So it's a separate little algorithm. So let's write that one. Def, let's copy this to save me typing. Def, move elements right, and I'm just going to put pass in at the moment so that my program doesn't crash. And I've got to think of what I'm going to give this function, what arguments I'm going to send in. So I need the array, which is D. I need to know where I'm going to be inserting. And that is going to be at position +1. That's my start. And then I need to know where the end of this array is, otherwise I will have an error. So I'm going to copy that and paste it in there. So let's put this back to the way it was. That was an underscore and that was a 4. So what I'm really doing is sending in the data. Position is going to be 0 in this first instance because I need to place it there. So I need to start at position +1, which is that item there, and I need to have the end of the sorted part, which again is that item there. So in this case, going through the loop, they're going to be equal, but I've got to move that 4 from there into that position there. And I'll do it inside move elements right. So I've sent in my parameters. So let's do the, I've sent in my arguments. So let's do the parameters on this one. So D, let's call this one position to insert. And the last one is the current element. So let's just code this quickly. It's another while loop because I'm just going to look at this and I'm going to move it right if I need to. In fact, I know where I need to insert at the current element. So I need to move my 4 into current element, and that leaves me the position to insert here. So really what I'm doing is moving everything right as the function says. So to do that, I need another while loop because it might not, well, I just don't know how many elements. It might be a really long list. So I'm going to keep doing it while I've got elements to move right. And in this one, I've only got 1. So while the current element is greater or equal to the position to insert, so let's copy that. Now I've probably lost you by now, so don't worry. So while the current element is greater than position to insert, what I need to do is swap these items over. So that 4 is going to go into that blank space there. So that 4 is at the current element. So the data at the current element. Now, what's happening is I've got to kind of move this space backwards. So this space is going to go left, and that's going to give the appearance of this 4 moving right. So the data at the current element, is going to equal D at current element minus 1. So what's happening there? Oh, let's put my blank back. What I'm doing is picking up the data at the current element, which is my blank, and I'm placing it at the position before. And then I just need to change the current element to be what was there. And it's going to keep doing that. It's going to keep looping round, moving the position, the blank, one place to the left, one place to the left. So actually it's moving the items to the right. And there's a reason for that, because if I'd got this list, let's say that I'd got an ordered list, this might make a bit more sense. And I'm looking at placing the 3. The 3 is going to go between the 1 and the 4. So what I've really got to do is move the blank to that position and move the 4 one space right. So that's what I would have, and then I can insert my 3 at that position. So once it's gone through the loop and it's done the insert, I'm going to return the new array, which is sorted, back to the main program. But I've only got a blank. I only know where I need to insert the part. So I've got to do exactly the same here. Now that I've got the position and I've moved the things out of the way, I'm going to insert my item at that blank place. That's it. That's the entire insertion sort. So what I need to do is return it to the main program because it's a function and it needs to print the item out. So I need to return it to the main program, return D, and hopefully everything should work and I have an insertion sort. So let's just put that back and run my program. Fingers crossed. And there we go. We have an array that we started out with 4, 1, 3, 2, and it's given us a sorted array. So it works. Very difficult. I will give you the code. You don't need to type it out. If you could understand anything that I was doing, that's a bonus. If you don't understand everything I was doing, it really is not going to affect you at all. You just know that programming is a little harder than you originally thought. We can change the data. So I can put in any sort of list. Let's do 5, 3, 2, 6, 9, 10, 3. I've got 2 3s, notice. And if I run my program, I'm hoping that that will sort them out nicely. I'm going to save it first. And there we go, 2, 3, 3, 5, 6, 9, 10 in order. So it's working. Now, what I would like to do is give you a version of this where you can see at each step what is happening through the loop. So I'm going to put a print statement in here. I'm going to do the same with the bubble sort in a second. So if I put print D there, so I'm printing out my data at each step of the way, and I run it this time, you'll see that it will show you the sort taking place. So if you do it by hand and run this program on the same set of data, this should show you what you should be getting at each step. So that's the insertion sort. I shall link that into your page as the file. You'll need to copy and paste it into a Python editor window and save it to make it work. And I shall do exactly the same with the bubble sort. So let's go and find the bubble sort. Have we got the bubble sort? I've got my merge sort. Yeah, I've got a bubble sort down here. So let's open that. Desktop bubble sort. Let's open that. So if I run my bubble sort on my data, let's just do the same. 4, 1, 3, 2, and just check that this is a working version. And there we go. Now this is the bubble sort, and I've already put in the print statement so that you can see every step of the process in a bubble sort. Now you've probably got something to compare the two different sorts on how they work, how many times they go through a loop, how many comparisons they make, so you can judge which one is a little bit more efficient. And you can also do it with the merge sort. Now the merge sort I haven't written. There's a version of it online which I have stolen and given to you, but I do link and credit them. But I didn't want to explain how a merge sort works because it's beyond the knowledge required for the course. So in other words, it doesn't use an array, it uses a list, and with a static array it's always the same size. With a list we can have lists of different sizes, and it does that. It starts off with a large list, breaks it down into single element lists, and then merges them together to produce a large list. That is not possible with a static array. This also uses something called recursion, which I gave you a version of the bubble sort with recursion. It's a very special method of calling itself, and if I run this program, you can see that we get a lot more information on the splitting of or the breaking down of a list. Now what it does is it takes the first part to merge and breaks it down into that. Notice it doesn't even bother with the second part at the moment. Then it takes this list and breaks it down into that. Then takes this list and breaks it down into that. And it keeps doing that over and over again, and it finally rebuilds the list in a merged way. But if you do the merge by hand, you should pretty much see how this program works. So you can put the list that you use to merge sort into here where a list is, and you should see the same methods that you've used by hand. And I've also converted this to Python 2.7 from Python 3. So if you go to the website that I show you and copy and paste theirs, it might work, it might not, because that was written in Python 3. And I've changed the items there and the print statements to also be Python 2.7. So it's up to you. You've got the three sorts, bubble sort, merge sort, and insertion sort as code. So you've got something to actually run and play with and see what happens. Remembering these algorithms is going to be very, very difficult. You won't be asked to. You won't be shown these algorithms at all. And if you are, you'll only be asked, what does swap do? Okay, so you'll only be asked for a tiny little bit of what the code does if you see it in the exam. You won't be asked to repeat it. You won't be asked to write it. You may be given, rather than the full code, you may be given the pseudo code. So we'll look at the pseudo code a little later on, as I said, for revision. But these programs are there for you to run, not to write. I don't expect you to write or come up with any of these whatsoever. Sorry that the video is so long. Sorry that it's a bit complicated. I've probably made a mess of it as I was going along in my explanation. But just be aware that the versions that you will need will be the ones that I've done by hand with pen and paper, and nothing of these at all. So that's the sorts dealt with.